Hello and welcome back. In the past video, I spoke at length about strings, how to manipulate strings, how to create strings, how to work with strings, and some of the ways in which we can use them as data in our research. In this video, we're going to be doing something kind of similar, but instead of looking at strings, which if you remember were just a series of characters formed by quotation marks, either double quotation marks or single quotation marks, in this video, we're going to be doing the same thing, but with numbers. And if you remember from my second video on ways of storing data in Python, I talked about how there were essentially two different kinds of numbers. These are things you have to be familiar with. There are integers and there are floats. Integers are digits that do not have a decimal point. Floats are digits that do. It's important that you learn that now. I've simply kept our very similar setup with by creating a couple different objects here, with A1 being equal to 1 with no decimal, and same thing with A2 and 2, and B1 being equal to 1.0, so it's a float, and B2 being equal to 2.0. This is what we're going to kind of be using throughout this entire video. And with just using these basic objects, we're going to go through and we're going to talk about how to convert integers and floats into strings and why that's important. We're going to talk about how to convert strings into integers and floats, why that's important. We're also going to talk about how to convert floats into integers and integers into floats. Manipulating numbers in Python is one of the most important things to learn with numbers if you're working in the digital humanities. And throughout this video, you're going to see a couple examples of why that's particularly important for us. Another thing we're going to be talking about is how to basically use integers to perform basic mathematical functions: addition, subtraction, multiplication, exponential multiplication, which, and if you're not like a math person, this is, think of the things you learned back in sixth grade, to the power of. So 2 to the power of 10. Remember when it had that little 10 up to the top right corner of 2? Yep, that's exponential math multiplication. We're going to be talking about how to perform division and a few different types of that: regular division, modulo division, and floor division. Then we're going to be talking about probably one of the most important things to learn when it comes to numbers is how to use comparison operators, which is just a very fancy way of saying the things like equal to, greater than, less than, etc. And we're going to work very, very loosely in this video, very, very minimally, with while loops and for loops. I'm not going to be fully introducing these until it looks like lecture number 9. However, I'm going to simply use these in this video to give you an idea about why we, even though we're primarily text-based in the digital humanities, why you should still care a lot about numbers in Python. So with all that said, let's go ahead and get started. So if you remember correctly, Python is an object-oriented language. So I've got a couple objects here that we're going to be working with, some floats and some integers. So the first thing that we can do, just to kind of refresh your memory, is we can use our print function and print off A1. And A1 is going to return 1, which is what we want to see. We can print off B1, and we should see B1 being 1.0. And in our output down here, we do see 1 and 1.0. So that's the print function, just to give you a little refresher on that. Let's say, however, we need to not really read these things as numbers and floats. We want to read them as strings. In Python, you can very easily convert any integer or any float into a string by using this command here: str, and in parentheses, put A1, or whatever number you want to see registered as a string. And if I print this off, we will see 1 down here. Now, I know what you're thinking, it looks exactly the same. How is that any different? While you cannot see the difference, Python does. And this is very important to understand. The reason why you need to understand the difference between strings and integers, even though you don't see a difference out here, is when you're trying to use them in Python. So if I'm going to open up a text file, I'm going to create one called text. Let's call it text1.txt. And I'm going to make Python put this in this specific folder. And I'm going to talk about with functions in a much later episode. This is just right now for giving you a sense of why you should care about them in this video. So we're going to create a text file, and it's going to be put into this folder right here, the one that we're working in, 04 underscore integers. And we want to make it, we're going to use I got an international keyboard, there we go. A plus, which is going to make it where we can append to it and create it if it doesn't exist. We're going to set it as F. Essentially, we're going to open it up and have it work as F. Now, if I need to create this text file, but I don't want to just write text1, I want to be able to use it as a string, but I want to add in something. I want to add in an integer. I want to add in a1. Let's see if I can do that when I try and do this. So I'm going to just simply f.write something cool. Wonderful. Okay, now this would normally work if a1 were a string. We'd have no problem at all. In fact, let me demonstrate this by making a new object, test, just to demonstrate what I am talking about. You're going to see right over here, text, test, and it created perfectly fine. There's no issues whatsoever. What it's done here is it's read this text file that's going to be created. If we open it up, we'll see something cool is written there. Wonderful. And we're going to see that I've added in those things to add those two strings together, and it's going to create that text file. What happens, however, when I do this? I get an error. Why have I gotten an error? Let me look down here, and I see that I have a type error. And the type error tells me specifically that I cannot do this because a1 is an integer, not a string. Have no fear. I can convert a1 to a string by doing that. And now you see it's created the text file text1. Even though in the output, these two things, 1 and 1, look identical to us, Python reads them as something very different. And that's why you should care. For what we're going to deal with, how we're going to work with integers in a much later episode, this is why you need to spend time now and actually learn them and learn how to convert them and play with them, even in this basic state. I'm going to explain all of this and how I'm doing this much later, though. For right now, I want to continue by showing you how to convert things. So let's say you have a float, and you want to get rid of that pesky decimal position. So let's take b1. And now what we're going to do is we're going to, let's delete that. What we're going to notice is that even though b1 here is an object of 1.0, it's going to have an output of just 1. Why has it done that? Because I've told Python to print out b1, but convert it to an integer. In other words, get rid of that decimal place and make it not a float anymore. I can do the same thing with a1 by converting a1 into a float using this command, float and in parentheses a1. And notice that now I'm printing off a1, which is an integer, but now it has a decimal point, 0.0. That's because I have told Python to read a1 and convert it into a float. This is very basic, but very important, and it's going to be very, very useful as we progress through these lectures. Now, let's say you need to perform basic mathematics. So let's say we need to take a1 plus a2. Oh, helps if you print things off. I need to print off the results of a1 plus a2. And look at that, math has held up once again. 1 plus 2 is equal to 3. Let's say we need to multiply. Oh, and by the way, I have simply done this by using a plus sign. Now notice here, I should specify this, that the plus sign isn't simply combining these two as it does if we were using two strings. So if you remember in our last video, equals test2. If I were to print a3 plus a4, it's going to combine those two strings because they're strings. But Python knows to read these objects differently because a1 and a2 are integers, which is why it's performing a mathematical function and adding them together. We can do the exact same thing with the multiplication function by multiplying these two together. Notice down here that 1 times 2 is 2. Let's do minus. Same thing, -1. And we can do the same thing with division. 0.5. Okay, that covers our basic mathematical functions. We can also do exponential multiplication by using two asterisks, as we do here. Let's change a2 to 10. Oh, that won't do it. Let's change this to 5. Now we're going to do essentially 5 to the second power. And look at that. Pi squared is 25. Math is held up. Let's do pi cubed. Change that to 3. And 125 is our answer. Fantastic. Now, let's do some other basic, or other forms of division. We can do modulo division with a percent sign. Let's do 6 and 2. Oh, that's why. Let's pick an odd number. We'll do 9, and let's do 9 here, divided by 2. Okay, so in this math equation, I have simply done something like this. I have done 9 divided by 2. And the result of 9 divided by 2, as we know, is not going to be a whole number. What this is going to return to me is the remainder. So it's going to perform 9 divided by 2, and then it's going to say, hey, I was able to do this, but I still have 1 left over. That's why we're seeing an output down here of 1, and that's called modulo division. What about floor division? We can do floor division with 2 of these division symbols. And what this is going to tell me is how many times it was able to do it completely. It was able to completely do a 9 divided by 2 4 times. So that's how you do different kinds of division. I kind of went through that kind of quickly, mainly because you can go back, pause, rewind, and look at those in more depth. But let's move on to something that is a lot more useful for DH, and that's going to be our comparison operators. You probably haven't thought about these since 5th grade, but guess what? We're going to think about them right now because we are going to use them in almost every single thing that we program because it is vital. And I'm going to demonstrate the utility of these operations by creating a series of while and for loops. Because oftentimes when you're working in DH and you're looking at your data, you need to iterate through and perform loops on your data. And the way in which you iterate through things is by using these operation symbols. So we're going to work through them right now on a very basic level, and we're going to really see their utility and power in future videos as we start working with code more hands-on. Okay, so for right now, let's print off a simple thing. 3 is equal to 3. Notice here that in order to do equals, I have to do 2 equal signs. This is important. If you do 1 equal sign, this will not work. You have to do 2 equal signs so that Python doesn't read it as an individual a variable being set. So I'm going to print off that result. And if you look down here, Python has told me that it is true. Now, I haven't talked about this yet. I'm going to in a later video, but this is a Boolean. It's simply an true or false return. It's another way of handling data in Python. If, however, I write print 3 that equals 2, it's going to return false, because guess what? 3 does not equal 2. Wonderful. The same thing can be done for 3, 1 greater than 3, and going on down the list. And I provided here for you a nice little cheat sheet. Equal to is structured like this with 2 equal signs, greater than just like you're used to, less than just like you're used to, less than or equal to, less than symbol and an equal to, same thing with greater than and equal to. And to make a not equal to, you use an exclamation mark and a 1, and if you notice, or an exclamation mark and an equal sign, and if you notice down here, you see it working. 1 does not equal 3, so it comes back as true. So go back, and if you need a refresher on all those, go back and just rewind and do that. I'm going to speak now about the utility of these comparison operators. You will oftentimes have to make things called loops. And I'm going to speak a lot about loops in lecture number 9, but for right now, let's work through some of the basics of how we're going to be using these. You'll oftentimes make a loop using while. And while I is greater than 10, let's say you want to iterate through something 10 times, print off I. And we're going to do I is equal to I plus 1. So it's going to iterate through all this that many times. Oh, that would have done nothing. Make it less than. Well, I is less than. Ah, that's why. I equals 0. There we go. Wonderful. And if you notice down here, let me explain what I did there. I made a simple mistake. I was telling Python while I is less than 10. The problem was, however, I was not yet an object. And I needed, in a while loop, you need to work with an actual object. So I created I as an object and made it an integer of 0. And so what it's doing here is it's saying that while I is less than 10, it's going to print off I being whatever I is. And at the end of this, it's going to say I equals I plus 1. In other words, it's going to add one digit to I. And it's going to keep on iterating through this loop until I is greater than 10. Or greater than or equal to, in this case, a 10. And what that's going to do at that point is it's going to immediately cut off. And we see this out right here in the output. While this does not look useful right now, it's going to be very useful because this is going to be one of the ways in which we iterate through our data. And I'm going to speak more about this in a later video. Right now, I'm just trying to show you how it's actually useful. Another time that you're going to use this is in for loops. For I in range, I'll explain the range function later. I equals I plus 1. Print 1. Print I plus 272. Why not? Let's just do that. Hash all that out. And right here, we see being able to go through for I and range 10. We see I being plus 272. This is a very simple way of making a for loop. I'm going to explain the difference in a later video. But what we want to do is specifically say, let's say we want to say I print I is greater than 5. And it's going to turn false all the way through until it gets to 6. And notice it goes through, and we see the booleans being returned as false, 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 and then true, 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 true. This does not really explain to you how useful these functions are all going to be in later videos. This just demonstrates that they have some utility. When we start playing with while loops and for loops, you are going to see why I spent so much time in this video explaining numbers, but not just numbers, but explaining how to manipulate them and how to have them added together and how to actually compare them. That's all I'm going to cover in this video. In the next video, we're going to start looking at ways in which we make this data relational. And we're going to do this over the course of the next 3 videos in Lecture 5 on tuples, Lecture 6 on lists, and Lecture 7 on dictionaries. But thank you for listening. Have a good day.